Hi, my name is Nicole and I'm a CS61B TA. In this video, I'm going to do a quick recap on inheritance, static and dynamic types, as well as casting, and kind of go into some of the tricky parts that students seem to struggle with. And then I will do question 3, the extra question from the discussion worksheet. I know that in my section, I personally didn't have enough time to do the question, but I think it's really important and it tests your understanding of the concepts at a deeper level. Alright, so let's start with an overview of static and dynamic types before we jump into question 3 from the worksheet. Alright, so first of all variables in Java must have a static type. This is the type that we declared the variable as. So for example, in this line of code, animal A, all we're doing is making a new variable named A of static type animal. And remember, so in Python, we're allowed to say x equals 5, but in Java, this is not allowed. You always have to declare a variable before you use it. So you have to say int x before you can say equals 5. Okay? So this guarantees that all variables have a static type. And furthermore, we can only declare a variable once. So the static type doesn't change throughout the entire life of this variable, okay? And here, notice we can declare a variable on the same line that we also assign it. So this brings me to assignments. So when we assign a variable by using equals, this affects its dynamic type. The dynamic type is what kind of object the variable actually points to. And we're allowed to reassign variables as many times as we want, so the dynamic type can change, okay? So here are a couple lines of code. So we already declared the variable A to be of type animal, of static type animal, I mean. And now we say A equals new dog. And what this does is now the dynamic type of A is dog. Okay? And now notice on the next line I say A equals new cat. And this is totally allowed. I'm allowed to point my animal pointer to a dog as well as a cat. And so here the dynamic type is now cat. Whoops. Okay. And the reason I'm allowed to point an animal to a dog is you can think of variables as boxes, and boxes hold a certain thing. So boxes can only hold the static type of the variable. So A is an animal box, okay? And so I can only put animals inside of this animal box. So I can put a dog inside of the animal box because a dog is a type of animal, right? So I'm assuming that there's a hierarchy. So there's like an interface or a class animal, and then both dog and cat inherit from animal, making dog and cat subclasses of animal. So you're allowed to put an animal or anything more specific than an animal, any subclass of an animal, into an animal box. Now let's step back and talk about the compiler. All right? So Java has compile time and runtime, and they're two very different things. So think of the compiler as a very cautious proofreader, okay? It keeps an eye out for potential mistakes in your code. And this is a good time to talk about alternative names for static type and dynamic type. So static type is also known as the compile time type. All right? This is the type that matters when we're compiling. The dynamic type is the runtime type. This is the type that matters when we're actually executing lines of code. Okay? Now, the thing is, the compiler only knows the compile time type, the static type. Okay? So the compiler has to proofread your code with limited information. And it turns out that the compiler decides to err on the side of caution. All right? It sometimes thinks that there is a mistake, even if at runtime there wouldn't be an error. Right? So here are a couple lines of code as an example. Animal A equals new dog. All right, so I'm just going to write this out explicitly. So animal A, this declares A to be a variable with static type animal, and then equals new dog sets the dynamic type of A to be dog. Okay, and remember this is allowed because we're allowed to put a dog into an animal box. Now, the next line of code, let's say that we try to do A.bark. Okay, and at this point, the compiler's proofreading your code, and it sees this line and it's like, okay, what is the type of A? And from the point of view of the compiler, the type of A is animal. And then it's like, can an animal bark? Well, not necessarily, right? Like, can a fish bark? Probably not. So at this point, the compiler throws a compile error because it sees this and is like, you're trying to call the method bark on an animal. However, an animal cannot necessarily bark. Okay? So how do we avoid this? In cases like this, we have to promise the compiler that at runtime, A will in fact be a dog. And this is precisely what casting is. Casting is just a promise to the compiler. So before, the compiler thought, okay, A is an animal and animals can't bark. Oh no, I have to throw a compile error. So with casting, we can tell the compiler, like, hey compiler, I know that you think that A is an animal, but I promise you that at runtime, the dynamic type of A is actually a dog. So don't freak out, just calm down, don't throw a compile error on this line of code. And then the compiler's really trusting. The compiler's like, okay, fine, I'll take your word for it, and moves on. And then this line of code does compile, and in fact, since A does point to a dog, this line of code would execute perfectly fine as well. Okay? But now the natural question to ask is, well, what if we lied? What if we break our promise? Well, then at runtime, we would get an error instead. All right, so here's an example of that. Suppose that we had actually said animal A equals new animal. So now animal has the static type, or A has the static type animal and the dynamic type animal. All right, so now we do the same thing. We cast A to dog and then call the bark method. Okay, so same thing, we promise the compiler, like, hey, I know A looks like an animal, but I promise the dynamic type is dog. So the compiler's like, okay, fine, I'll take your word for it. And then at runtime, we double check. So at runtime, it's like, well, let's just make sure that we actually followed through on our promise. And if A actually pointed to an animal, then this cast would throw a class cast exception because it isn't a dog, and so you broke your promise. Okay? So now this brings me to an important note. So when I was a student in 61B, casting had me pretty confused. I thought when I saw the line dog A, that A was actually being turned into a dog. Like A was actually changing in some way. But I just really want to emphasize that casting does not change the type, neither the static type nor the dynamic type of an object. Okay? All it is just a promise between the programmer and the compiler that allows us to bypass a compile error. All right? So now let's move on to the actual exercise. So this is question 3 from the discussion 4 worksheet. And I know that a lot of TAs didn't actually get to this question, and I think it's a really important question. In fact, I didn't even get to it because I ran out of time. So I think it would be great to really understand how this question works, to really drive home these points, these subtle points about static versus dynamic type. All right, so the instructions say, cross out any lines that cause compile time errors or cascading errors. And all that means is if I cross out a line and the lines after it depend on that line, then just cross out all of those lines. All right? and then put an X through runtime errors. I'm actually going to write when I cross something out, whether it was a compiler or a runtime error. But anyway, don't just limit your search to main. There could be errors in classes A, B, and C as well. And then finally, what does d.main output after removing these lines? All right, great. So this is a good time to say that static versus dynamic types are a very testable topic. And so there's a lot of trick questions that can come up with this, and it's in your best interest to understand them. All right, so let's start at class A and see if there's any errors in here. So we make a new instance variable x, and we set it equal to 5. Okay, that looks good to me, so I'll just put a little check mark. And then we define a method m1, which prints out some stuff, and that looks fine to me as well. And then same with m2, we just print out some stuff, and notice I can say this.x or I can say x, and the keyword this is not necessary unless the variable x was ambiguous. So if we actually took in a variable called x, we would have to use the keyword this to differentiate between whether you mean like the local variable x or the instance variable x. So anyway, so this is fine. And finally, we have an update method that changes x to 99. Great. So now class B extends A. Cool. So now we're actually seeing some inheritance, so that's a good sign. So we're gonna set up a little hierarchy here. And this just means that B is a subclass of A. So the way that this like extends keyword works is it's always subclass extends superclass. All right. And by just including this extends keyword, now Java knows that you're inheriting anything from A, all right? Or you're inheriting everything from A, really. But anyway, so even though we don't explicitly have an instance variable x in our B class, we inherited it from A, so it's implicitly there. All right, so now we define a new method m2, and here that like sounds really familiar, and if we look back in class A also had an m2 method, and so these two method signatures are exactly the same. So I'm gonna write that this is override. Okay, so when two method signatures are exactly the same between a subclass and a superclass, the subclass overrides that method. Okay, and the next method is m2, which takes in an integer y. So this brings us to our other term, which is overloading. So if the name of the method is the same, in this case m2, but the arguments are different, then it's overloaded. Okay? And that's also another really tricky thing that comes up a lot in exams. And then finally, we make a brand new method, m3, that is unique to B, so A doesn't have it. Okay? And it looks fine to me as well. All right, let's move on to class C. So same thing, class C extends from B, and so we add to our hierarchy here, and then by extension, it also inherits stuff from A. All right? So even though, once again, we don't explicitly say public int x equals 5, it is implicitly here. Okay? Public int x equals 5. And so the next line of code is actually completely fine, because we've already defined x to be the number 5. So this is the same thing as y equals 6. Okay? All right, great. And now the next method after that is m2. And so yet again, I have the exact same method signature. So this is override again. And then m4, there's actually an error inside the implementation of m4. And that is this line right here, super.super.x. So when Java sees something like super.super, whoa, super.super, it thinks that you're looking for an attribute called super inside of your super class. So it's like, okay, what is C's superclass? It's B. Does B have an attribute super? No, it doesn't. And so then Java's super confused. All right? So super is not an attribute of the class. It's just a special keyword. Just like how this was a special keyword, same thing. So you can't do super.super. Okay, so we're going to cross that out because it's an error. And we're going to use the red color to show like, oh, it's super wrong. All right, cool. And then now let's switch back to blue. And then finally we make an M5 method, and that looks fine too. Cool. Now the exciting stuff, we can actually go down to class D, and actually I'm going to move my hierarchy down here so we can refer to it. Okay, so D's main method is where all the stuff happens. So let's go ahead and get started. And same as before, I'm going to keep track of like a static and dynamic type chart. And then in addition to that, I'll also keep track of the X attribute, because remember that it's a instance variable, so each instance of the class will have its own X, and similarly Y if applicable. All right, so starting with BA0. So this is the declaration. So that says, okay, make a new variable A0 with static type B. And now we say equals new A. And now if you just think about that for a second, is this okay? No, it's not, right? So if we look back at our hierarchy, and let me move it up a little bit more because it's like all up in the charts business, but anyway, so if we look back at our hierarchy, so think of this as like animal, and B is dog, and C is poodle, right? We are trying to put an animal into a dog box, right? We're trying to set a variable of static type B to point to an object with type A, and that's not okay. All right, so this line of code is actually wrong. The compiler figures out that you're trying to put an animal into a dog box and throws a compile error. Okay, and so A0 does not get to be in our chart. And then because the following two lines use A0 as well, we're going to cross those out because they're cascading. All right, cool. So now we do kind of like the reverse of that. We make a variable B0 with static type A. And now we point it to a new B object. So now this is okay because we're putting a dog into an animal box. So that is fine because a dog is an animal. And that is always true. Like a subclass is and then superclass. So since we pointed to a new instance of B, the dynamic type is B, and we inherit X from our class A. So X is 5. And Y is only applicable for class C, so not applicable here, and I'll use a dash for that. All right, cool. So that was all fine. And now we do system.out.println of b0.x. So so far we've only really seen like the compiler checking methods and checking assignments, but the compiler also checks when you try to access attributes. So it'll check like what is the static type of b0, and that's A. So it'll go and look inside of the A class to see if you have an attribute X, and we do. So the compiler's like, okay, well then that's fine. And so then we print out 5. All right, so moving on, b0.m1. So like all of these method calls are going to get a little bit repetitive, but it's only because I really want to drive home the point that the procedure is always the same, right? When you first start out with inheritance and static and dynamic types, it seems like there's a bunch of rules and it's really arbitrary, but I want to show you that there's actually a very simple procedure that the compiler follows and then the runtime follows. And if you just remember that simple procedure, then no matter how tricky the questions get, you'll be golden. So what happens is during compile time, the compiler is like, what is the type of B0? And remember, the compiler only knows static types. So from the compiler's point of view, B0 is A. Okay? And so we look inside of class A for a method called M1, which takes in no arguments. And there is one in class A right here. Okay? So the compiler's like, okay, I proofreaded this line and it's okay. And then during runtime, we look at the dynamic type of the object. So we look, and we're like, what's the dynamic type of B0? And that is a B. So during runtime, we'll actually look inside of class B to see if we overrode the method M1, which takes in no arguments. So we look in class B and we don't find something there. So then we'll go up to the parent class, A, and there is an M1 method there. So we'll just go ahead and call the A's M1 method. And what that does is print out AM1, arrow, and then X, which is 5. Cool. So this gets a little more interesting when we call M2. So same thing during compile time. We look, what is the type of B0? And from the compiler's point of view, it's an A. And so we look inside of the class A for an M2 method that takes in no arguments. And we find it right here. So the compiler proofreaded the line and everything was fine. Then during runtime, we look in the dynamic class. So we're like, what is the dynamic type of B0? And it's a B. And so we look inside of the class B for an M2 method that takes in no arguments. And we find one right here, okay? So now we call this more specific version of M2. We call this overridden version, okay? So this will print out BM2 arrow X, which is 5. Cool. And now the third line, things get even more interesting, or at least in my opinion. So same thing, the compiler is going to do its proofreading. And so it's like, okay, B0 is an A. And now I'm going to look for a method inside the class A that takes in, or a method called M2 that takes in an integer. And now the compiler looks and it's like, oh no, there's no method M2 that takes in an integer. I must call a compile error. And so it does exactly that. Let's erase this first. So we will cross out this line of code and write compile error here. All right, great. Now finally we get a new variable, so we can add to our chart. B1, so we make a new variable B1 with static type B. And then we say equals new B, so we're pointing it to an instance of B, so the dynamic type is also B. All right, cool, so everything's fine there. Now B1.M2 of 61, so essentially we're trying to do the thing that we tried to do on line 27 but failed, and this time it is okay, because when the compiler does its checks, it sees that B1 is type B, because the static type is B. And now it looks in class B for a method M2 that takes in an integer, and it finds it right here, so everything's fine, and no compile error. And then during runtime, we look inside of the dynamic class of B1, which is B as well, and we run that M2 method. So that prints out BM2Y arrow, and then we print out Y, which was 61. All right, great. And now B1.M3, nothing special about this. Compiler goes, looks in the B class for an M3 method, finds it there, and then during runtime we call B's M3 method, and this prints out BM3 called. All right, great. So now A C0 equals new C. Great, we have another variable, so we can add it to our chart. So A C0 makes a new variable named C0 with static type A, and then equals new C sets the dynamic type to C. Okay? Oh, and I haven't been writing, so B1 also has X equal to 5, and Y is not applicable. C0 will also have X equal to 5. Oh. And then, now since we're finally using a C object, Y is applicable, so we say Y equals 6. Great. So now C0.M2 will be quite similar to B0.M2, where we look at the static type of C0, and we see it's an A. And then so the compiler goes and checks, does the class A have a method M2? Yes, it does. We've seen that over and over. And now during runtime, we're like, what is the dynamic type of C0? Well, the dynamic type is C. So we're going to look inside of the C class for an M2 method that takes in no arguments. And we find one right over here. And so we use the overridden method instead. So CM2, and then super.x, all that does is look for a variable x inside of the superclass, which is B, and B inherited x from A, so all is fine, and we just print out CM2 5. Cool. So now we say C1 equals cast A new C. Wow, okay, so there's a lot going on here. So let's try to sort it all out. So first, let's do our declaration. Our declaration. So we make a new C1 variable with static type C. Now let's parse the right-hand side, okay? So we have A new C. Wow, C looks a lot like a parenthesis. But anyway, so we make a new C object. So this returns sort of an instance of C. And then we cast it to an A, all right? So we're casting it to A. And in my recap, I only casted to more specific things, but we can also cast to more general things as well. So we can go up in the hierarchy as well, from C to A. But now what we've done is told the compiler that this object is really dynamic type A. Okay? So now the compiler's thinking okay, so the right-hand side is really an A object. And so now the compiler's oh, I'm trying to put something of type A into a box that's meant for things of type C. So if we think about our analogy, we're trying to put an animal into a poodle box, okay? And that's not all right. So this line, even though we were so close for it to be all okay, we have to cross it out with a compiler error just because we casted to type A. All right? So compiler error. All right. So now C1 doesn't get to be in our chart either. And now let's move on to the next line of code and go back to blue. So A1, so we make a new variable A1 with static type A equals, and then we cast to A C0. So here's where I want to re-emphasize that casting does not change the type of anything. So we look and we're what is C0? Okay, it's an object with static type A and dynamic type C. All right. And actually, it would have been fine to just say AA1 equals C0 because something of type A is allowed to go into a type A box. Remember this, the whole compiler only sees static thing. But just to be more explicit, this line of code casts C0 to A, but that doesn't change anything about C0. All that does is flag the compiler that C0 is really an A. And then the compiler's well, that's okay because this is an A box anyway, so everything is fine here. But A1 will be now pointing to the same thing that C0 pointed to. So let's imagine in memory we have C0 is pointing to a C object in memory. So now what we're doing is we're saying, okay, A1 equals what C0 is. So A1 will also point to that exact same thing in memory, right? Even though there's a cast there, that's okay. Once we bypass the compiler, just ignore the casting, okay? So A1's dynamic type, it adopts the dynamic type of C0, so it becomes C as well. All right, and then it adopts everything else, so 5 and 6 as well, all right? And I'm actually going to keep this around so we remember that C0 and A1 both point to the same thing. Okay. Now, C2 equals C of A1. All right, so that's fine. So let's do a new variable C2 with static type C. Okay. And then we're going to assign it to A1 with the cast to C. So A1 does have static type A, but because of the cast, we promise the compiler that it's okay, so the compiler doesn't throw an error. And then during runtime, C2 also points to the same thing that A1 points to, and so it'll also be dynamic type C, and then 5 and 6 for X and Y. All right, cool. So we've done these 2 lines of code. Now C2.M3. Cool. So now we're back to doing some static method lookups. So we're like, okay, what is the static type of C2? Well, it's a C. And so we're going to look for a method called M3 inside of the C class. So we go up, and inside of class C, there actually isn't explicitly an M3 method, but remember that C extends B, so we inherit any methods that B might have. So let's go look at the parent class, which is B, and we find an M3 method right here. So then the compiler did its proofreading and didn't find anything wrong, so everything's fine there. And then during runtime, we repeat that process with the dynamic type of C2, which is also C. And so now we'll look for an M3 that takes in no arguments in C inside of the C class. Don't find it there. Once again, we inherit from B, so we call B's M3 method, which prints out BM3 called. All right, cool. Now we do C2.M4. And if we remember, we had to cross out M4 because it had an error. So this does not work either because it's a cascading error. I'll just write down cascading here. Okay, moving on, almost done. C2.M5. All right, so same thing. What is the static type of C2? It's a C. We look in the C class for an M5 method, and we find it there. Nothing exciting about this one. And then during runtime, we call C's M5 method, and it prints out CM5 and then Y. And C2 has a Y. It is 6. Cool. And actually, I'm going to write down X is 5 here and Y is 6 here, just to make it seem a little more box and pointery. All right. Now, I want to call C0, C0's M3 method. Before I do that, I want to cast, so tell the compiler that C0 is really a C. And if we look, it actually is a C, so we know that there won't be a class cast exception at runtime. But anyway, so at this point, because we promised the compiler that C0 is really a C, the compiler believes us and doesn't throw any sort of compile error and thinks, okay, fine, C0 is a C. And C0 adopts or inherits B's M3 method. So everything's fine there. And then once again, at runtime, we will call B's M3 method. And same thing, B M3 will be called. All right, so I actually like this line of code a little more because it's more interesting. So here is just exploring that casting, you have to put parentheses around it in order for it to cast before it calls the method. So here we actually won't cast before we call the method, we will cast after the method already returns. So what happens is we look and we're like, what is the type of C0? And since we haven't casted it yet, its type is A in view of the compiler. So we look in the class A for an M3 method that takes in no arguments. Oh no, we don't find it there. So the compiler's like, hey, this is a mistake, I shall throw an error. And so this is also a compile error. Okay, and then finally, just 2 more lines left. B0.update. All this does is now we look, what is the static type of B0? It's an A. We look and find an update method in class A, and lo and behold, there is one. So everything's fine in the compile time. And then during execution time, we're like, what is the dynamic type of B0? And it's a B. And so we'll look inside of the class B just in case update is overridden, and it's not. So we use A's update, and we set X to be 99. Okay, so up in our chart, X shall be 99. And now finally, we're going to call b0.m1. Same thing, we do our compile checks. We check whether there's an m1 method in the class A. Yes, there is. Then during runtime, we try to see whether m1 is overridden in our dynamic type, which is b. So we look, and there isn't an m1, so we'll just use our default a1. And this prints out am1 plus x. So am1. And now since we have updated, x is 99. All right, great. So hopefully that gave you a good idea of how tricky these static and dynamic type questions can get, and also was reassurance because I never had any arbitrary rules throughout this. I had the same procedure over and over again, which is just put yourself in the eyes of the compiler. And so remember that the compiler only sees the static type, so it only sees this half of this table, right? And so therefore the compiler has to make all of its proofreading decisions based only on the static type. Then during runtime, we have new information. We have the dynamic type as well. And so at that point, we can look inside of the dynamic type class to see whether or not maybe we overrode a method or something like that.